Welcome to episode 18 of the Welding Codex. This is a podcast for those who want to learn more about the technical side of welding. Welding codes, heat treatment, weld defects, metallurgy, and all the subjects that you may have come across but didn't have time to get into too deeply. We have Gary Martin sitting in for Peter Kinney today. In this episode, welding engineers Gary Pace and Gary Martin cover Clause 8 of AWS D1.1 Structural Welding Code Steel. Clause 8, Strengthening and Repair of Existing Structures. Gary Martin will be updating us on the changes between 2015 and 2020 versions of the code. Anyhow, thanks for joining us. Before we get going, time for the advertisements. If you're on a budget and looking for an online CWI training course, check out train-eng.com. Train, and it's like a minus sign, eng.com. The Part A online course is $149. Part B is $129. Train-ENG also has the CWI course split out, so if you only have a few areas that you'd like to brush up on before the CWI exam, check out one of the buffet-style options. Train-ENG.com has an online course that covers modules 6, 8, 9, and 10. This course covers Module 6, which is Metal Properties and Destructive Testing, Module 8, which is Welding Metallurgy, Module 9, Weld and Base Metal Discontinuities, and Module 10, Visual Inspection and NDE Methods. All of this material is covered for $75. CWI Part A question bonanza is also $40. If you'd like to make a donation to help keep this podcast alive, visit my website, texasweldingengineering.com. Also check out my YouTube channel if you get the chance. Just Google Gary Pace Welding ASME or one of those words, and there's going to be something that pops up. Anyways, I've got a lot of material posted on that platform. Welcome to the Welding Codex. Welcome to the Welding Codex. Today we've got Gary Martin with us. We're going to be talking about one of the shorter, more compact clauses in AWS D1.1, strengthening and repair of existing structures. Gary, welcome. You want to give us a little of your background?
Yes, I'm a kind of a hybrid welding engineer. I did my undergraduate at LeTourneau and my graduate degree in the Ohio State University. Very hands-on, practical welding engineer for the first 15 years of my career. I practiced what I preached and kept my hands on welding. In the later years, not as much, but I do weld at home, so I keep my hand in it that way as well. I'm on the AWS committee, particularly the D1 Structural Steel Committee, and also the Sheet Steel Committee or Subcommittee, which is a separate book, D1.3, and also I'm on the inspection and fabrication task groups that feed into the D1.1 code. And that's where I met Peter Kinney, who's one of your normal hosts.
Yeah, Pete's not with us today. He's out on vacation. So I don't know when I approved that vacation, but I guess we'll have to work on our paperwork. So we're going to talk about strengthening and repair of existing structures.
So again, commensurate to my membership on the committee, my opinions and interpretations expressed here are my own and in no way reflect any official position of the AWS.
Strengthening and repair of existing structures. My universe view or worldview of this is there is a lot of stuff that was built long before the codes really got dialed in. So a lot of times as construction, engineering, whatever, you might run into a situation where you're running into an existing structure and you don't know what it is, or you have a sort of an idea of where it is. And to me, this is, or you know exactly what it is, but this clause is to give you guidance in going in that direction. Any thoughts, Gary?
Yeah, I mean, this was in here originally, and then they subsequently created a D1.7, which is a whole book on this, which actually refers back to this. The D1.7 only supports the D1.1 code. It doesn't support, any of the other, stainless, sheet, titanium, or any of the other codes. It's strictly dedicated to supporting D1.1. And it's, 20 pages or so, a little bit more in depth. I mean, this is almost sort of a commentary, not really a lot of requirements, because in the scope, the beginning, the first paragraph, it says the engineer is going to have to, prepare a comprehensive plan for the work. And so this is just giving some guidelines to that. And more of a suggestion clause.
Right, and it's like you say, it says right there, strengthening or repairing an existing structure shall consist of modifications to meet design requirements specified by the engineer. The engineer shall prepare a comprehensive plan for the work. Such plans shall include, but are not limited to, design, workmanship, inspection, and documentation. Except as modified in this section, all provisions of this code shall apply equally to the strengthening and repair of existing structures, including heat straightening of distorted members. So it's like you say, this is more or less a guideline, or hey, did you remember to do this? Or this would be a good starting point. I think this is trying to, Pete's words, this clause is trying to set the engineer up for success, is my opinion of this clause.
Exactly. And what it says there, whatever you're going to do to strengthen or repair the structures, you got to use qualified materials, qualified welders, qualified procedures. Inspection criteria applies and so forth. But as far as actually how you're going to attack it, that's pretty much in the engineer's lap.
So it starts us off with base metals. You got to figure out what you're doing. 821, investigation. Before preparing drawings and specifications for strengthening or repairing existing structures, the types of base metals used in the original structure shall be determined either from drawing specifications or from representative base metal tests. Before you even start, you need to know what you're welding or going to weld, or what you're going to be preparing to weld. Suitability for welding. Not everything is designed to be welded, especially some of these older materials. They might not be something you want to be welding on. So that's what 822 tells us. 823, other base metals, where base metals other than those listed in table 3.1 are to be joined. Special consideration by the engineer shall be given to the selection of filler metals and WPSs. Any thoughts on this one?
Yeah, I mean, there's a shall term in there, but it could also just be should. I mean, because there's no real requirement there. It's kind of a suggestion. Hey, you need to consider this. And you're talking about suitability for welding. If you come on a structure that is riveted and then you're going to apply weld repair to it, you got to be real careful.
Yeah, and this is just telling the engineer, because a lot of times the engineers doing the design of these structures aren't welding guys. They might be a structural engineer and they've kind of dabbled a little bit in welding and materials, but that might not be their strong suit. So this is giving them an idea that, hey, take a second before you dive into this, take a time out, do a little investigation, let's figure out what we're doing and put a plan together. And this is a good starting point for our plan. And base metals, like you say, if it's riveted, you probably really want to consider if you want to be welding on that material before you strike an arc on it. You want to be damn sure that it's weldable material.
And most engineers know the responsibilities that they have when they're signing the documents. And if they don't know something about welding, they're going to get a welding expert consulting in on the job before they sign on the dotted line.
8.3, design for strengthening and repair. 831, design process. The design process shall consider applicable governing code positions, other parts, and general specifications. The engineer shall specify the type and extent of the survey necessary to identify existing conditions. It's just telling us that the engineer needs to go through the design process. 832, they need to do a stress analysis. 833, a fatigue history. 834, restoration or replacement. 835, loading during operations. 836, existing connections. And 837, use of existing fasteners. I kind of covered some ground there, but what do you think? I think we can kind of condense a lot of that down, can't we?
Well, yeah, I mean, they have to be kind of brief and vague on all this, because this is a wide range of applicability of structures that could be 100 years old, talking about riveted connections and such. And maybe you can't re-rivet it, and welding is the only option. And, you need to look at all the circumstances that exist in that design to allow you to do that.
8.4 fatigue life enhancement. 8.4.1 methods. The following methods of reconditioning critical weld details may be used when written procedures have been approved by the engineer. And it tells you, profile improvement, toe grinding, peening, TIG dressing, and toe grinding plus hammer peening. You want to work your way through that list?
So this is a perfect, I have a real life example of this. I worked for GE Oil and Gas, and we acquired Lufkin, which makes the nodding donkey oil pumps that you see in West Texas and other areas. And we had a fatigue cracking issue on that structure, and we actually went in and used this section to devise a fatigue life enhancement of those structures due to one of the welds aging prematurely. And it involved a lot of these items: toe grinding, TIG dressing. We did all of that, extend the life of those structures, and it applied. So typically this gets into where you've got something that's happening on very large scales. And also the wind industry is going to face this as well, because you've got thousands and thousands of wind towers, and they're highly fatigued, and they'll get cracks. And instead of taking the whole tower down, you'll want to go in there and try and extend the life of those structures. Same with the oil pumps.
It gets back to Pete hit on this earlier. Pete and I touched on it, but with toe grinding and profile improvement, with toe grinding, you're trying to take out a place where you could get a stress concentration going and end up with a bad situation in regards to possible failures. Number 4, TIG dressing, reshaping the weld toe by the remelting of existing weld metal with the heat from a TIG torch. So basically you're just kind of running a little wash pass with a TIG torch over there to get rid of any undercut or any profile situation that wouldn't be good for the end use of the structure. Toe grinding plus hammer peening, same thing. You're just kind of getting that toe of the weld to a contour situation that matches a long life. 8.5 workmanship and technique. Any thoughts here, Gary?
Well, so this is setting the stage for, you've got an existing structure, so you're going to have rust and paint and all types of stuff on there that you would not typically encounter in new construction. So it's saying the base metal's got to be repaired, and the surface of existing base metal in contact with the new base metal shall be cleaned of dirt, rust, and other foreign matter except adherent paint film. And it goes into the Steel Surface Painting Council, SB2, surface preparation, hand tool cleaning. Portions of such surfaces which will be welded shall be thoroughly cleaned of all foreign matter, including paint, for at least 2 inches from the root of the weld. So this is basically saying, you're going to repair something, weld repair, it needs to be clean, give you the best shot at making a quality weld.
Yeah, and that gets back to, just general practice as a welder, or being in the welding universe, operating as a welding professional, getting paint and any kind of deleterious material out of there before you strike an arc is a pretty basic idea from day one when you start welding in high school or trade school or wherever you pick up the trade. So member discontinuities, 8.5.2, when required by the engineer, unacceptable discontinuities in the member being repaired or strengthened shall be corrected prior to heat straightening, heat curing, or curving or welding. Before you start bending things, you probably want to fix the unacceptable discontinuities, but it gets back to when required by the engineer.
Yeah, so if you've got a structure that has suffered some deformation or damage due to a weld failure and you're restoring it, you're likely to have some cracks, fissures, delaminations that you're going to have to take care of before you complete your weld repair.
Right, and we've got 8.5.3 weld repairs. If weld repairs are required, they shall be made in conformance with 5.2.5 as applicable. 8.5.4 base metal of insufficient thickness. The base metal having insufficient thickness to develop the required weld size or required capacity shall be as determined by the engineer. 1, built up with weld metal to the required thickness. 2, cut back until adequate thickness is available. 3, reinforced with additional base metal. Or 4, removed and replaced with base metal of adequate thickness or strength. So that's just giving the engineer a few options on which direction they want to go to build up the base metal if there's insufficient material there to give them what they want in regards to, their loading situation. Thoughts there, Gary?
Yeah, again, this has to do with the wild, wild west of whatever you encounter in your repair or restoration application. You're going to have maybe corrosion, or the engineer comes up with a weld design exceeds the capability of the base metal to carry it. So yeah, it gives you some options of what to do in those circumstances.
Well, and it gets back to what, how to approach something. If you don't know anything about repairing or existing structures or whatever, this just gives you an idea. It's a starting point. It's not meant as an all-encompassing guide. It's just hey, this is a great starting point because we don't know what in the heck you're going to encounter. You might encounter a railroad bridge that's been sitting there for 100 years. You need to really do some investigation of, how you're going to approach it. And I don't know if a railroad bridge would be the perfect example, but, from a metallurgical standpoint, the materials they were using in 1910 may or may not be what we use now in regards to structural applications. So this is just giving you a starting point, but it's also giving the engineer a few options that, hey, these are some things that you might want to think about before you dive into this. As you said, Gary, the wild, wild west of what you could encounter out there.
Interesting note is the commentary on this clause is longer than the clause, and there's a lot of good illustrations and documentation on this topic in the commentary. So when you start going through that, you're gonna have a little bit longer discussion on this.
855, heat straightening. When heat straightening or heat curving methods are used, the maximum temperature of heated areas as measured using temperature sensitive crayons or other positive means shall not exceed 1100 degrees Fahrenheit for quenched and tempered steel, nor 1200 for other steels. Accelerated cooling of steel above 600 degrees F shall be prohibited. You want to dive into that? Give us a little crash course on metallurgy there, Gary?
I've actually seen a lot of this done, and a lot of people do it incorrectly. Number one, they heat it way above those temperatures till it's cherry red. And so what you're trying to do is you're using a heating pattern to get the steel to move. It's typically a V pattern in the opposite direction of the bend. And this is saying, it's giving you some temperature limitations. And the other thing is when they heat straighten, they tend to heat it up till it's cherry red and then hose it down with water. They want to get it to move fast. And both of those things are deleterious to the material properties, both the heating above those temperatures and rapid quenching. So this is a very important guideline when it comes to doing that.
Especially when you're dealing with, I don't want to diminish the other steels, but quenched and tempered steels, you really want to be careful with those and how you deal with them in regards to heating them, and any variation or anything that's coloring outside the normal. I don't know how other to say it, but quenched and tempered, anytime I see those words and I'm attached to something, those are big red flags, and you really want to proceed with caution with those materials because they tend to be a little less forgiving than your garden variety carbon steels that you might encounter in Group 1 and Group 2 on Table 3.1 of D1.1.
Well, the problem is if you heat them hotter than that, you're going to over-temper the steel and weaken it.
Right, you're going to turn it into a mush, basically. You're defeating the idea behind quenching it and tempering it. 856, welding sequence. In strengthening or repairing members by the addition of base metal or weld metal, or both, welding and welding sequence shall, as far as practicable, result in a balanced heat input about the neutral axis to minimize distortion and residual stresses. Here it gets back to what we discussed in a previous episode. You just don't want to take off on one side and just weld the hell out of one side of a structure and have it bow on you or just deformed to beat hell, and then have to figure out, oh man, how are we going to get this to go back to where we wanted it to go? So that's what this is telling you. It's just telling you think twice before you really put a lot of heat into a part, because it could have consequences that are very costly and damage the material beyond repair. Thoughts there, Gary?
And well, that cost could apply to any fabrication, but it's more poignant here because in new fabrication, you tend to be balancing your welding about a neutral axis, say a fabricated beam or something. You have to, weld it from independent pieces, so you are balancing the welding. But here, in this case, you've already got an existing structure and it only needs a weld on one side. You need to put a little bit more thought into what's going to happen distortion-wise when you start welding that up.
Okay, 8.6 quality, 8.6.1 visual inspection. All members and welds affected by the work shall be visually inspected in conformance with the engineer's comprehensive plan. 8.6.2 NDT. The method, extent, and acceptance criteria of NDT shall be specified in the contract document. So
yeah, and that's again kind of a style guide boo-boo there. They should have just referred you to the inspection clause because they're repeating exactly what's said there anyway.
So that wraps up Clause 8. There's not a lot to it. I've only dabbled in it once or twice in my career, and it kind of got kicked over to the AWSD 1.7, is it?
Yes, but that's a fairly new book.
Yeah.
The first edition.
Yeah, it got kicked over there. I kicked the engineer over there. This was 3-4 years ago. So said, hey, take a look at this before you dive in and get too crazy with everything. But anyways, that wraps up Clause 8. Anything you want to say or contribute on the way out the door there, Gary?
No, again, I only had a brief experience with this late in my career, so I've given about all the info on that I know.
All right. Well, Gary, hey, thanks for joining us.
Thanks for having me.
Everybody, thanks for listening, and we'll talk to you later.
That wraps up Clause 8, Strengthening and Repair of Existing Structures. If you have any questions or comments, please contact me at gpacex@gmail.com. We're going to be finishing up AWS D1.1 in the next few weeks, and then I don't know what direction the podcast is going to take. If you have any episode suggestions or any subject topics that are code-related, please feel free to contact me. Another advertisement on our way out the door. If you're on a budget and looking for an online CWI training course, check out train-eng.com. The Part A online course is $149. Part B is $129. Train-ENG also has a CWI course split into sections so that if you only have a few areas that you'd like to brush up on, you can check them out. One is a buffet-style option that covers modules 6, 8, 9, and 10. This covers Module 6, Metals Properties and Destructive Testing. Module 8 covers Welding Metallurgy. Module 9 covers Weld and Base Metal Discontinuities. And Module 10 covers Visual Inspection and NDE methods. All this material is covered for $75. If you don't need to brush up and you don't need the full meal deal, train-eng.com also has a CWI Part A question bonanza. Just nothing but CWI questions. And this is for $40. So anyways, check out train-eng.com. Thanks for listening to the Welding Codex.